Good morning. Hello, class. You are welcome to today's lecture. We are looking at interest theory today. Now, this is the overview of what we'll be looking at in this topic. So we'll start with, sorry about the first one, it's not hard. We'll start with an introduction, and then we'll move on to the effective rate of interest, and then simple interest and compound interest, present value, the effective rates of discount, nominal rates of interest, and then we will look at force of interest. So by way of introduction, interest may be defined as the compensation that a borrower of capital pays to a lender of capital for its use. So it's a form of rent. In theory, capital and interest, they need not be expressed in terms of the same commodity. All right, so to explain, for example, when you walk into a bank for a loan, they assess you, and if you qualify for the loan, they will give you the loan. So if they're giving you an amount of 50,000 Ghana cedis for example, to start up a business or whatever it is you need a loan for, they will give it to you expecting that you pay back in the future. Now, in the future, based on what the agreement is, whether it will be in the next year or 2 or 10 years, you will pay them back 50,000 and then something more. And that is that extra money you pay the bank back is what we call the rent. So if they give 50,000, you will not give them 50,000 back. If they give you 50,000, you will return the 50,000 plus an extra. That's because they have given you money that is not yours for you to use. Okay. And to pay, you have to pay for it. It's more like you are renting that money or that capital. Yes. So it's important that you pay that money, okay, and then you pay it back with some rent, some form of rent on it. So that form of rent is what we are calling interest. It works in the other way too. If you lend money to somebody, you may take interest because the person is denying you the use of that money for a period of time. That person has the advantage of using that money for that period. If the person goes to use it for business, he or she may make profits, a lot of profits over the period that he has the money. So if he has to return the money to you and he's giving you exactly the same money in two ways. Number one, he has been able to have the money and use it to earn more when you could have done the same, but you sacrifice the money for him. Number two, by the time he brings the money to you, the value of the money would have depreciated, all right? So if you gave him 10,000 cedis, okay, what that 10,000 could do at the time you gave him today, in the next 2 years when he returns it, that 10,000 cannot do that much. It's just as today, given how inflation has risen so much, if you bought an item for 1,000 cedis last year, it definitely isn't 1,000 cedis today. It is 3,000 cedis or more. So that is the reason why when money is lended or borrowed, interest is charged on it. Some relevant times we want to look at. So what's the principal? The initial amount of money that's invested. So let's look at this in the form of you as an investor going to put your money into some form of investment. So the principal is the initial amount of money that you put in. So recently I bought a T-bill with the government in January. That amount of money that I used to buy the T-bill is my principal, which because it's the initial amount that I am investing at the beginning of the investment. Let's look at accumulated value, all right? Accumulated value. This is the total amount received after a period of time. So as I give an example, the T-bill I bought in January, it was a 90-day T-bill. It will mature in the month of April. at the end of April, the government will pay me not exactly what I put in. They'll pay me more than what I put in. So the total amount I'll receive by the end of April becomes my accumulated value. So that's the amount I put in, the principal plus the interest, all right? I receive all of it. So I'm definitely going to get more money than I put in January. How about the amount of interest? This is the difference between the accumulated value and the principal, okay? So whatever money I'm getting in April, if I subtract what I put in January, the difference there becomes my amount of interest. So if I put in 1,000 cedis in the month of January, and by the end of, and in the month of April, when my investment matures, I'm getting 1,100. The difference between 1,100 and 1,000 is 100 cedis. So the amount of interest I have earned is 100 cedis. How about the measurement period? The measurement period is the unit in time, the unit in which time is being measured regarding the investments or the contracts. So in this case, I bought a 3-month or a 90-day T-bill. So the measurement of interest is days, okay? If you are working in terms of years, if you bought a 5-year loan, or if you bought a 5-year investment, then the measurement period is years, all right? Okay. How about accumulation function? Okay, accumulation function, AT. Now this function gives the accumulated value at time t greater than or equal to 0 for an original investment of 1. So if we invested 1, then AT becomes the accumulated value at time t, which is more than or equal to 0. So if t is 10 years, then AT is the function that will give me the accumulated value at time 10. Okay. We are saying for an investment of 1 because we are assuming that our principal is just 1. If our principal was, say, P, so we'll get there. We'll come to our function and we'll get there. So we are saying that some important aspects of the accumulation function are that A naught is equal to 1. Because if I invested 1, then my accumulated value at the same point that I am invested at the same start of the time of investment is 1, because time has not elapsed, no interest has been earned. All right. AT is generally, the second point says that AT is generally an increasing function if the interest is not negative. So once your interest is not negative and it's positive, your accumulation function continues to increase, because if you invest something today, your accumulation function takes you to your accumulated value. So with an amount invested today, tomorrow it gets bigger, the next year it gets much bigger, and the following year it gets much, much bigger. So AT is generally increasing, all right? The third point says that AT will be continuous if interest accrues continuously. So it takes the form, or it follows the order of, or the nature of your interest. Okay, that's how come if interest is not negative, it will continue to increase. So if interest also accrues continuously, then it will also increase continuously. Now let's look at the amount function, okay? We use capital A instead of a small a. Now the accumulated value at time t greater than or equal to 0 of an original investment of K. So the amount function is representing that amount of money I will receive at the end of my 90-day T-bill, okay? That is my amount function. So it's a function. It's a function because we are talking here in terms of variables. No specific value of T or K has been given, okay? So I mentioned initially that we are considering investing amounts of 1, but usually we don't invest just 1 cedi or $1. We invest amounts more than that. So we'll use the variable K to represent the amounts that we are investing, okay? So the amount function K is equal to K. Sorry, let me properly write this. It's not well written over here. Okay. So I want to properly write the amount function here is not well written. Let me illustrate it better for you. When I'm giving you the notes, I'll do what to correct it before I give it to you. Okay. So we have been talking about the amount function and the accumulation function. And we are now on the amount function, and we are saying that AT is equal to K times AT. All right. And then A naught is equal to K. That is if an amount of investments, the principal is K, and then AC here is our accumulation function, okay? So this is the correction I want to make instead of as you see it in the notes. All right. So you realize that this accumulation function is taking our principal K to our accumulated value, which our amount function is standing in for, okay? So the amount function is a variable or the function that is representing our accumulated value. All right. So usually we'll use a timeline for our demonstrations. So this is the time of investment where you put in your principal. And then here is the time of maturity, okay, where your investment comes to an end and you are paid back your accumulated value. And this is simply your principal plus whatever interest you have earned over the period. We now want to look at amount of interest. Now, this is the amount and during the end period from the date of investment. So, for example, with my T-bill investment I did in January, the amount of interest involved is what I'm earning in April minus what I put in the month of January. Okay. So IN is a function or a variable being used to represent the amount of interest. So you can choose any two periods in the course of your investments. If you are doing a 10-year investment, you may be interested in finding out what is my amount of interest in the second year. So that will be interest, that will be accumulated amount at the end of the second year minus your accumulated amount at the end of the first year. Okay. Now we want to look at the effective rate of interest. So these are all relevant and important definitions and terms you need to understand when you are studying interest theory. What is the effective rate of interest? We are using I to represent our effective rate of interest. It is the amount of money that 1 unit invested at the beginning of a period will earn during the period, where interest is paid at the end of the period. It is the amount of money that 1 unit of investment at the beginning of a period will earn during the period, where interest is paid at the end of the period. This definition is equivalent to I being equal to A1 minus A naught, or yes, that's it, A1 minus A naught. Okay. So A1 here is your accumulation function at time 1, and A naught here is your accumulation function at the beginning of the investment, given that we are considering a period of just 1. The alternative definition is given below. I is giving us your accumulation function at time 1 minus the accumulation function at time 0, all divided by the accumulation function at time 0. Okay. So if you want to look at the effective rate of interest during the nth period from the date of investment, then we have IN giving us the amount function at time n minus the amount function at time n minus 1. That's the period before n. Okay, all relative to the amount invested at the beginning of the period. That is at time a n minus 1. Okay. Now the effective rate of interest is often expressed as a percentage, and the amount of principal remains constant throughout the period. The effective rate of interest is a measure in which interest is paid at the end of the period. Okay. So we'll end our first session here. See you in the next session.